Through the years, the Cadillac ride has won acclaim as being the most comfortable and luxurious in the fine car field. Even on rough secondary roads, the Cadillac suspension absorbs nearly all of the jolts and harshness caused by surface irregularities to provide an outstanding combination of ride and handling characteristics. Today, however, the majority of all driving is on smooth roads, and higher driving speeds are the rule rather than the exception. Under these conditions, the ride quality of any car is primarily controlled by its wheels and tires, for on smooth roads, the damping effect of the suspension is very slight. So for a smooth, vibration-free ride, the roundness or concentricity of each wheel must be held to very close tolerances. The flex rate of each tire must be uniform for its complete circumference, and each wheel and tire assembly must be precisely balanced. When all of these factors are present, ideal ride quality is the result, for the distance from the wheel hub to the road remains constant to provide a smooth, level ride. Comparatively, a non-concentric wheel, a non-uniform tire, or an unbalanced wheel and tire assembly will cause the wheel hub to oscillate constantly as the suspension is forced up and down with each wheel revolution. At low speeds, these vertical movements are hardly noticeable, but at 60 to 75 miles per hour, these oscillations occur at a rate of 12 to 15 times per second, a critical frequency in car response, and the result can be a distinct disruptive ride roughness or vibration. On later 1970 Cadillacs, however, the possibility of such wheel or tire-induced ride disturbances has been substantially reduced. For since early February, all wheels and tires used in Cadillac production have been qualified for maximum concentricity and more uniform tire force ratings. These improvements are the result of new technology and new equipment now in use at Cadillac and the manufacturing sources. For Eldorado production, General Motors Research designed and built two highly complex automated machines to assure optimum tire and wheel quality. This highly sophisticated equipment is completely new in automobile production. The first machine checks wheels for concentricity as they are received from the supplier. For this measurement, the machine pilots and drives the wheel from its hub, while runout detectors ride against the inner and outer bead seats on the rim. Any variation in the dimension from bead seats to the wheel hub is computed automatically, and if the average runout exceeds specifications, the wheel is rejected. All Eldorado wheels meeting this strict concentricity standard are moved to the automatic tire mounting and inflation stations, and once these operations are completed, the assembled wheels and tires move into this large complex for tire force variation correction. In this machine, the tire is run against a rotating drum adjusted to impart a 1,400-pound load against the tire. This corresponds to the average wheel loading on the Eldorado. With the tire rolling against the drum, the force variations within the tire caused by slight irregularities in rubber thickness, ply splices, or sidewall strength are measured and monitored by a unique memory system. Then grinders placed 200 degrees beyond the measuring point remove 1.5 thousandths of rubber from the outer tread ribs for each pound of force reduction required. As the grinders and drive drum retract and the wheel slows to a stop, the force variation correction is monitored by the memory system, and any tire still exceeding the acceptance limit is sprayed red and rejected. While the grinding of the outer ribs is hardly visible, the correction achieved is substantial, for after grinding, the maximum allowable force variation is limited to 15 pounds. Following force variation correction, the wheel tire assembly is balanced both statically and dynamically to assure the best possible ride quality. This new production equipment in use at the Cadillac plant now assures consistent tire and wheel quality for all Eldorados. And while the equipment used is different, The wheels and tires for all rear-drive Cadillacs are now qualified for concentricity and uniform tire force ratings by their individual suppliers. While only qualified wheels and tires have been installed on Cadillacs built since early February, in some cases, ride disturbance problems may be encountered on cars built before these improvements entered production. When a ride disturbance problem is encountered, owner information can often help pinpoint its cause, for the source of the vibration could merely be a problem of wheel balance, as opposed to a non-uniform wheel-tire assembly. To aid this determination, ask the owner when the problem began. For example, if the car had no ride problem when delivered, but one developed sometime later, the most likely cause is an unbalanced wheel. This could result from a thrown wheel weight or a puncture repair where the tire was demounted. If the owner states that a tire repair has been made, simply rebalancing the wheels may correct the problem. But if the condition has been present since the car was delivered, wheel-tire non-uniformities are the most probable cause, and a ride test should be made with the customer to pinpoint the condition. Before starting the ride test, check all tires for proper inflation. On rear-drive cars, the recommended pressure for all 4 tires is 22 pounds cold, while the Eldorado requires 24 pounds at the front and 20 pounds for the rear. All of these pressures would be up to 4 pounds higher if the tires were hot. Because wheel and tire-induced roughness or vibration is most pronounced in the medium to high speed range, the ride test must be performed on a road where speeds from 50 to 70 miles per hour can be driven safely. When the ride disturbance speed is reached, hold the car at the exact speed where the roughness or vibration is most pronounced. Then observe the car reactions to determine whether the condition is being caused by the front wheels or the rear wheels. If a front wheel is causing the disturbance, a distinct vibration or quivering motion will be felt through the steering wheel, steering column, or floor pan. If the condition is severe, the hood and front fenders may noticeably shake. Comparatively, if the roughness or vibration is originating from a rear wheel, the reaction in the car will be felt mostly through the seats as a shake or vibration. In most cases, the ride disturbance will isolate itself to either the front wheels or the rear wheels, for a roughness or vibration problem is usually caused by just one wheel and tire assembly. Following the road test, place the car on a hoist and raise it 4 to 6 inches from the floor. To allow the front suspension to hang free, position the front post beneath the frame lift points. The first approach to isolating the specific wheel causing a ride disturbance is to drive the wheels at high speed, one at a time. If a heavy-duty wheel spinner is available, there is no need to retract the front disc brake shoes. While being spun at balancing speed, an offending wheel and tire assembly with excessive radial runout will usually cause a distinct throb or pulsation that will be felt through the spinner handle. To check for unbalance, release the wheel spinner and feel the fender or bumper as the free-running wheel coasts down. An unbalanced wheel will cause a roughness or vibration that can be felt by touching the fender or bumper. By checking both front wheels for radial runout and unbalance in this manner, the problem wheel-tire assembly can usually be isolated. For correction, the offending wheel must be removed, but after rework, it should be reinstalled in its original position on the hub. To assure this, mark one wheel stud and its mounting hole before removal. Since the original wheel-tire relationship produced a ride disturbance, changing the tire position may reduce this problem. So mark both the rim and tire at one place as illustrated, then fully deflate the tire. Loosen the tire beads from the rim and turn the tire around on the wheel until the mark on the tire is directly opposite the mark on the rim. By re-indexing the tire on the wheel in this manner, the effect of any wheel-tire irregularities should be reduced, for it has been found that an offending wheel and tire usually results only when the stiff spot or high spot of the tire is near or in line with the high spot of the wheel. The distortion that results from this kind of wheel-tire relationship will create a ride disturbance. But by re-indexing the same tire on the same wheel 180 degrees from its original position, the resulting wheel-tire assembly is more uniform, so a smoother ride will result. Experience has proved that re-indexing the original tire is usually more effective than tire replacement, and less work is involved. Once the re-indexed tire is remounted and inflated, it must be reinstalled on the car in its original position. So align the marked stud and mounting hole. Since a problem wheel is being remounted, install the 5 wheel nuts in a crisscross pattern and spin them down until they are just snug. Then, following this same pattern, uniformly hand tighten each of the lug nuts to 90 to 120 foot-pounds. The use of a hand tool is definitely recommended, as this assures proper wheel piloting and reduces the likelihood of wheel or hub distortion. To complete the correction, the re-indexed tire must be rebalanced both statically and dynamically to assure the smoothest riding wheel-tire combination possible. We'll discuss the isolation and correction of rear wheel disturbances just as soon as the operator turns the record.